Good morning, everyone. Welcome to week 5. I hope you're all doing well. All right. A couple things about week 5 is that there's 4 different shapes that we're going to talk about the area of this week. Or how can we find the area of a parallelogram? How can we find the area of a triangle? How can we find the area of a trapezoid? How can we find the area of a regular polygon? All right. Now, I'm going to split this up into 2 videos. All right. Today's video is going to talk specifically about how to find the area of a parallelogram and how to find the area of a triangle. Tomorrow, I'm going to have another video. It's going to talk specifically about how to find the area of a trapezoid and how to find the area of a regular polygon. All right. So it's going to be split up into 2 parts, the videos for this week. Your assignment for this week, however, is a combination of all 4 of those shapes all together on one assignment. All right, so there's only going to be one assignment this week. All right, but there's 4 different sets of notes for it. All right, once again, today's video will be about parallelograms and triangles. Tomorrow's will be about trapezoids and regular polygons. All right, so I hope you're all doing well, and I'm going to get started now. All right, so the first thing we're going to talk about is the area of parallelograms. All right, and if we think back to 2 weeks ago, a rectangle, all right, is simply a type of parallelogram because the top and bottom are parallel, the left and right sides are parallel. The special thing about a rectangle, though, is that it had 4 angles that were all right angles, or 4 angles that were 90 degrees. All right, now I'm hoping, all right, that when you've talked about how to find the area of a rectangle before, all right, you're familiar with the length of a rectangle and the width of the rectangle. All right, generally the length is the longer side and the width is the shorter side, but generally in the past you probably used the area of a rectangle is length times width. All right, that's perfectly fine if you want to use that. All right, but if you look underneath there, all right, we use a couple different words. We use the word base, all right, and we use the word height. And then we say area equals base times height, all right? It's the same thing, all right? We're just changing the words from length and width so we can generalize it more for all of our other shapes, all right? Because, for example, a triangle doesn't have a length and a width, but it can have a base and a height. A parallelogram also doesn't really have a length and a width, but it can have a base and a height. So the reason we're introducing that here, all right, is so it's consistent through all the shapes that we're going to talk about. All right? Now, important thing about the height, and you're going to see this in several spots on all the notes so far, is the height of any shape, not just a rectangle, is perpendicular to the base. Meaning, in order for something to be the height, in order for something to be a base, all right, they have to have a right angle between them. All right? So, we can pick any side, notice, to be the base. All right? All right, it's just a side. However, we need to pick a base so we know the height. And that'll come into play a little bit more with parallelograms and especially a lot more with triangles later. All right? But a base only has a height if there's a line perpendicular to it. All right? Notice this phrase, it's going to come up about 3 or 4 times today. The height and the base must be perpendicular. They must be a right angle. All right? Here you got a couple of examples, and it's just the formula for you again down here. All right? The area of a rectangle is base times height. All right? This first one, 6 centimeters times 2 centimeters. All right? Is 12 centimeters squared. Notice the squared, all right? Now we're talking about area that's 2-dimensional since we're multiplying. So our label or our units become centimeters squared. 4 centimeters times 8 centimeters, length times width, or base times height, equals 32 centimeters squared. 1 and 5, 5 centimeters squared. Also, if you really want to, you can count all the boxes. All right? Now, we're going to move on to parallelograms. All right, and notice we're a little bit more general now, so we don't have right angles everywhere. All right, so C could be my base, but D is not the height. All right, or if D is my base, C is not the height because there's not right angles. So the area cannot just be C times D because there's no perpendicular side there. All right, so instead what we're going to do is we're going to take either set of parallel sides and we're going to draw a line from the top to the bottom to where it makes a 90-degree angle. All right? And then we're just going to get to the point where we can multiply base times height. But our height is not the slant right here. It's not this side. It's right here. It's that perpendicular distance going up and down. All right? They also give you a little visual proof here because they take this little triangle right here, they pop it right there, and now you get a nice rectangle as you go to the side. All right? So what we're doing is we're saying, hey, a parallelogram is no different than a rectangle. It's still base times the height, all right? Except for the height of a parallelogram, if there's not a rectangular or right angles, all right, the height is not one of the sides. So we have to find it. It's that little distance going up right there. Notice, once again, all right, the height and the base must always be perpendicular to each other. All right, now we got 3 examples down here. All right, the first one, just a normal rectangle, all right, like what we saw before. Base times height would be 2 times 5. All right, and we get 10 centimeters squared. Not really going to work through that one. All right, now, second one. All right, first thing to notice, well, is we have the height right here, all right, and the base is this whole thing. All right, well, the base is a little bit easy to figure out. It's not 12, it's not 3, it's the whole thing, which is 12 plus 3, which is 15, and then we got our base. All right, the height, we got to do a little bit more work. I'm going to come out here and draw that little triangle off to the side. It's a right triangle, so we can use the Pythagorean theorem. A squared plus b squared equals c squared. 5 is my hypotenuse, so it equals 5 squared. My a and b is 3 squared plus h squared. 3 squared is 9, plus h squared. 5 squared is 25, so h squared is 16. H is 4, as we see right there. All right, base times height is my area formula. 15 times 4 gives me 60 centimeters squared. All right, now, third one over here, there's actually a couple different ways we can do this. All right, the first way, or the way they have typed out there, is they decided we're going to split this into 2 rectangles. We're going to cut it right there. This top rectangle, base and height, is 2 times 10. All right, this second one, you got to be careful. This little part up here is 2, so this whole thing's not 7.5 anymore. It's 5.5 by 2. All right, that 2 because those sides are congruent. 5.5 because 7.5 minus 2 is 5.5. All right, we multiply all that out, we get 31 centimeters squared. All right, some of you might not do it that way. Some of you might decide, hey, I want to split it going up. All right, so we'd have 7.5 times 2 for that vertical triangle on the left side. All right, but now we're not going to take 2 times 10 because this part from here to here is not 10. It's 10 minus 2, which is 8. So that's 15 plus 16, which is 31 centimeters squared. All right, then there's 3 for you to try down here. All right, number 1 provides you with all the information you need. Number 2, you're going to have to split it up like we did on that last example up above, either 2 rectangles or maybe a rectangle and a square. All right, the third one is a rectangle, but you're going to have to use Pythagorean theorem to find the longer side. All right, as always, if you have questions on those, let me know. All right, that's it for the parallelograms. All right, now we're going to move on to triangles. All right, for triangles, all right, we actually have the formula 1/2 base times height. All right, some of you may have already heard that. All right, here's why though. All right, so we're going to make a rectangle of the base and height of the triangle. All right, this side's the base, this side's the height. Notice it's the same there as the triangle. All right, and notice that the triangle takes up half of that rectangle. All right, down here they have numbers. That's the same as 2, that white spot up there. This is the same part as 1. All right, so 2 of those triangles fit inside the rectangle. So the area of the triangle is half that of the rectangle. All right, our area of that rectangle is base times height. So our area of the triangle is 1/2 base times height. All right, it's simply just half of the rectangle. All right, we have it a little bit bigger for you right there. Notice once again, the base and the height have to be perpendicular. All right, they have to make a right angle. All right, that's always going to be true for a height. It has to make a right angle with the base. All right, it's going to be true for the next 3 weeks. We're going to talk about that a lot. All right, now down here you see a couple of examples. All right, your first one, just a basic one. They give you the height is 4, the base is 9. 1/2 9 times 4 gives you 18 centimeters squared. All right, the second one is a little bit more tricky because there are only right angles there, which means your height is 8, but they don't give you the base. All right, if you're like me, when I first looked at this problem, I'm like, oh, the base is 10, so it's 10 times 8 times 1/2. However, if we look closer, they don't tell me where I labeled as the base. They don't tell me that's the same as the 2 other sides. So even though the 2 other sides is 10, it might just be an isosceles triangle. All right. What we do know, though, is that height cuts the base in half. All right. So when I come out here and I can draw that right triangle, 10 and 8, I know this side right here, I'm going to call it x, because x is half of the base. It's not the whole base, it's half of it. So as I use Pythagorean theorem, 10 is my hypotenuse, so 10 squared equals 8 squared plus x squared. Well, that would give you 100 equals 64 plus x squared, which gives you x squared is 36, so x is 6. All right, I'm not going to show all that math. It's just the Pythagorean theorem worked out and solved like we did on the last one. All right, so x here is 6, but that's only half the base, so b isn't 6, it's 12. All right, now our 2 things that are perpendicular is the height, which is 8, and the base or side of 12. So my area equals 1/2 12 times 8, which comes out to be 48 centimeters squared. All right, looking at the third one, this one's a little funky, all right, because our right angle's outside the triangle. That's a little weird, all right? All right, and this 5.5 there, well, it's not a side of the triangle, so it can't be the base, but since it's perpendicular, it could be the height. All right, next, well, the only thing it's perpendicular to is this 6. But what about this little dotted spot out there? Do I need to account for that, or can I just use 6? All right, we can actually just use 6. This dotted part out there is just showing that it's a right angle, so we know 5.5 is the height. This 10 out here, all right, is just extra. We actually don't need it at all, right? Because our area is just 1/2 base, which is 6, times the height, which is 5.5. We multiply that out, we get 16.5 centimeters squared. All right. Next page just has some for you to try. All right. Number 1, notice it's all there for you. Number 2 is pretty similar to the one we just talked about. All right. 3, 4, and 5 are all going to require the Pythagorean theorem before you can solve them. All right. One last thing. On number 5, you actually have a couple of options. You have a right angle here for the triangle. So you could use that as a base and this as a height. You also have a right angle here. So you could also use that as your height and that is your base. All right. It's up to you which way you would like to go about solving that problem. All right. 4, you just got to draw a height from one of the sides down to the other side. I would recommend going that way because it looks a little bit neater. All right, and the Pythagorean theorem. 3 is just straight Pythagorean theorem to find the base and the height. All right. Key thing to remember, the base and the height must be perpendicular. They must make a right angle. All right. Guys, I hope you're doing all right. As always, if you have any questions, feel free to reach out to me and let me know. As I said, I will have the video over trapezoids and regular polygons up tomorrow. And I hope you're all doing well. Thanks, guys. Have a good week.